Hi, this is Miss Pellegrin, and today we're going to talk about random sampling. So I just Google searched random sampling to give you a definition. A random sample is a sample that is chosen randomly. It could be more accurately called a randomly chosen sample. Random samples are used to avoid bias and other unwanted effects. Of course, it isn't quite as simple as it seems. Choosing a random sample isn't as simple as just picking 100 people from 10,000 people. So when we are looking at random sampling, we want to make sure that we are choosing a sample that is actually random and we're not really looking at one particular type of people that we're choosing. So in order to look at random sampling, what we're going to do is we're going to look at some questions. Okay, and we're just going to discuss them. Okay, so this one says a student at a large middle school is planning to survey students about their favorite sport. Which of the following would ensure the survey is valid? A. Choose a sample that represents the student population. B. Only ask friends about their favorite sport. C. Ask 5 students about their favorite sport. D. Only ask 6th graders to participate in the survey. Okay, so A, as we can see to the right, is our correct answer. But let's talk about why B, C, and D are not correct answers. So B, only ask friends about their favorite sports. So then you would be limiting your sample. It would not be biased. So if, depending on the type of friends that you have, they might all prefer one particular sport. Ask 5 students about their favorite sport. So the part of that makes it not valid is that we're only asking 5 people. When we're looking at a random sample, we want to include a large amount. Now, when we're talking about a sample, if we want a sample of the population, we don't want to ask every single person in the entire world what their thoughts are. However, we do want to ask a lot of people because it would be impossible to ask absolutely everybody. And then D, only ask 6th graders to participate in the survey. So then it would be biased to 6th graders and what the 6th graders preferred as far as their sport. So we want to choose a sample that represents the student population, so all types of students. Okay, number 3. Josephine owns a diner that is open every day for breakfast, lunch, and dinner. She offers a regular menu and a menu with daily specials. She wanted to estimate the percentage of her customers who order specials. She selected a random sample of 50 customers who had lunch at her diner. Okay, so her random sample is of 50 customers who had lunch at her diner during a 3-month period. She determined that 28% of these customers ordered from the menu with specials. So 28% of these customers, who were these customers? Well, these were the customers that had lunch there. But what does she offer? She offers breakfast, lunch, and she offers dinner. So it says, which statement about Josephine's sample is true? The sample is the percentage of customers who order daily specials. Well, no, because it was only about the lunch people. So it's not who order daily specials because it did not include breakfast and dinner. B, the sample might not be representative of the population because it only included lunch customers. Okay, so not of the population because it only had those lunch customers, and she was only looking at the lunch customers who ordered her daily specials. Okay, so B sounds like the correct answer, but let's continue on. Let's check on C and D. C, the sample shows that exactly 28% of Josephine's customers ordered daily specials. Well, no, only it was 28% of her lunch customers. It didn't include her breakfast customers, and it did not include her dinner customers, because that percentage could go up or down depending on if she had more people at breakfast or dinner that did order those daily specials. So C cannot be our answers because it's not all of her customers. And then D, no generalizations can be made from the sample because the sample of 50 is too small. Okay, so 50 is not a too small of a generalization. The bigger we can make it, the better we're going to have our results, but 50 is a pretty good size for a random sample. So D is not correct. So B was our correct answer. Okay, let's continue on. Number 4. Max wants to find out the average number of video games purchased per student in his middle school last year. He plans to survey a sample of students. Which sampling method will result in the most reliable data? Okay, A, surveying 100 randomly selected 7th graders. Okay, so that would be biased because it would only be including the 7th graders, so it would be biased to the 7th graders. Okay, B, surveying one randomly selected student from each grade. So one is not enough people to survey. C, surveying 100 randomly selected students at a school basketball game. Okay, so because it's at a school basketball game, that is biased on people who attend the school basketball game. It's not including anybody at school. It's not choosing randomly anybody at the school. It is only looking at those people who happen to attend a basketball game. And if you don't attend the basketball game, then your opinion couldn't be counted. D, surveying 100 randomly selected students from a school directory. So school directory would just be, you have a list of all of the students and you just randomly choose 100 of them. So it's not based on any sort of bias. So D would be our correct answer there. Number 6. A librarian is reorganizing a collection of 640 books in the library. She takes a simple random sample of 8 books and records the genre of each book in the table to the right. Based on the sample, how many of the books in the collection are classic books? Okay, so the first book was fantasy. The second book she recorded was classic, and that is what we're looking for. The third book she got was romance. Then she recorded a sci-fi. Then she recorded another classic book. The next was a sci-fi book. The 7th book she looked at was a romance book. And the 8th book that she looked at was also a romance book. Okay, so out of the 8 that she sampled, 2 were classic. So we can write that as a fraction. 2 out of 8. We want to know how many out of the 640 total books were classic. So we want to know how many out of the 640 books. So we're able to set up a proportion because the 2 out of 8 should be proportional or equal to how many out of the 640. That is how our samples work. So I'm just going to solve my proportion. So 8 times x equals 8x. and 2 times 640. So 2 times 640 equals 1,280. And then in order to solve for x, we know that we can multiply each side by the reciprocal 1/8 or divide both sides by 8. We were just practicing multiplying by the reciprocal. X equals, so we're doing 1,280 divided by 8, which equals 160. So x is equal to 160. So 160 books are classic. Okay. We could continue that. We could say, okay, so then how many would be romance novels? Okay, so we had 1, 2, 3. So 3 out of the 8 were romance. We want to know how many out of 640 are romance. So again, we're going to do 8 times x is 8x equals 640 times 3 equals 1,920. And then we need to divide both sides by 8 or multiply by the reciprocal, 1/8, like we had done before. So x is equal to 1,920 divided by 8 gives me 240. So 240 of the books were romance. I only have 2 other types. So then we had sci-fi. There was 2 sci-fi. Well, that's still the 2 out of 8. So therefore we have 160 sci-fi because it was the same as the classic. And finally we had 1 fantasy. 1 out of 8 equals x out of 640. So 8x equals 640. So we're going to do 640 divided by 8. $640 divided by 8 gives me 80. Now, the reason that I am doing this is just to show you we already had our answer because it asked about the classic books. However, we said that there was going to be a total of 640. So if we added all that together, 160, 160, 240, and 80. $160, $160, $240, and $80. We should get that $640. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 4, 24, 2, 4, 5, 6, 640. So that helps to show us that we have done this correctly. Okay. Number 7 below is the data collected from 2 random samples of 100 students regarding students' school lunch preference. Make at least 2 inferences based on the results. Okay, so an inference is based on the data. So if we're looking at that data, what can we conclude about this data? And then to the right, you see that it says check student responses for correct justifications. So there's many options that you could say. You may say, okay, let's look. There is 74 students that preferred pizza out of 100 in the first sample, and in the second sample, there are 77 who preferred pizza. So we could say that more students prefer pizza than tacos or hamburgers. We could say that less than 50% of the students like hamburgers over pizza, because 12 out of 100 is less than 50%, 12%. Okay, we could say that if we took this, we could find the average, 74 plus 77. And then there was 2 of them to find the average, so divided by 2 equals 75.5. So 75.5%, because it was out of 100, prefer pizza, if we're just looking at those 2. So a lot of different things that we could look at. And we could do that for the tacos and for the hamburgers as well. Number 8. The number of apps that 16 randomly selected 7th graders in Lanyap Middle School have on the electronic devices. So they are looking at 16 randomly selected 7th graders. So they are only looking at 7th graders. They are specifying that it's 7th graders that they're looking at, and so therefore the fact that they're only looking at 7th graders is fine, because they're telling you that's what they're looking at. They're not looking at Lanyap Middle School as a whole, just of the 7th grade students there. If they said of a whole, they couldn't just choose the 7th grade students. And so there's their data. The first one had 16 apps, the second one had 5 apps, the third one had 8 apps, and so on. Based on these data, which of the following is the best prediction of the total number of all 247th graders in Lanyap Middle School on their electronic devices? Okay, so I have these numbers written down elsewhere so that I can see them while I'm using my calculator. So what we want to do here is we want to find their average. On average, how many students or how many apps does each student have? Okay, so we're going to find the average, meaning we have to add up all of the numbers. So 16 plus 5 plus 8 plus 3 plus 4 plus 4 plus 7 plus 13 plus 15 plus 8 plus 5 plus 9 plus 6 plus 10 plus 4 plus 5 equals. And then we have to divide by the number of pieces of data, which we looked at 16 students, so we're going to divide it by 16 to find the average. So the average number of apps on each student's device was 7.625. So on average, 7.6, I'm just going to round that up to 8. Oops. Okay. So I said rounding it up to 8. I'm actually just going to leave it as 7.25. or 7.625, 7 and 625 thousandths. So that was for each person, and we had a total of 240. So we want to multiply times the 240 students that there were. So times 240 gives me 1,830. So what answer was that closest to? And that answer was closest to B, 1,800 apps. So then finally, number 9, Milton's teacher asked him to find the average length of the words in the book he was currently reading. He decided to randomly sample the words. The list below represents his findings. So first of all, when we look at different levels of books, part of it is based on the size of the word. So that might be a reason that we are looking to see what the average length of the words in the book are. So his results are below, and we want to know what is the average length of the words in his book given the random sampling. Round your answer to the nearest whole. Okay, so this one's kind of interesting. A lot of times when we see average, we just add up all of the numbers and we divide by how many numbers, how many pieces of data there are. So you might think to do 8 plus 10 plus 15 plus 8 plus 5 plus 3. However, because we are looking for the length of the words, the fact that it's a 3-letter word and a 4-letter word is actually very important. So let's look at this data in a different way. Okay, so for 3-letter words, we had 8 3-letter words. 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to make a little note. For 4-letter words, there were 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 5-letter words, there was 15. And I'm just going to go ahead. I'm going to go ahead and write this down. Okay, so now that I've completed my little chart, let's look at these results and what it looks like. Okay, so we have 8 words that are 3 letters each. So what we really need to look at is we need to look at how many letters, so the number of letters out of the number of words to find the average. Okay, so in order to find the number of letters that is used, we would have to say, okay, this is the first X. It's 3 letters, and there are 8 of them. So 3 plus 3 plus 3 plus 3 plus 3, or the simpler way to do that would be to multiply 8 times 3. So 8 times 3 gives me 24. So there's 24 letters that were used here. And then 4 times 10, 40 letters in the second category. 5 times 15, which gives me 75. 6 times 8 is 48. 7 times 5 is 35. And 8 times 3 gives me 24. So then if I add all of those numbers together, +24 40 plus 75 plus 48 plus 35 plus 24. I get 246. 24, 40, 75, 48. Just double checking my stuff. Okay, so that's 246 out of how many words? So I had 8 words, 10 words, 15 words, 8 words, 5 words, and 3 words. So I need to add up those numbers. 8 plus 10 plus 15 plus 8 plus 5 plus 3 equals 49 words. So how many letters out of how many words? 246 divided by 49. 246 divided by 49 gives me 5.02. And it said round to your nearest whole number. So about 5 letters on average. And if we look, 5 actually was the one that had the most letters, or the most words that were 5-letter words. Okay, so that answer does make sense. We knew it would be somewhere between 4 and 6. Those had the longest, or the most amount of words. Okay, so thank you for joining us, and make sure to check back for other videos.